All right, so we're on to the last lesson of this unit, which is on the general term of an arithmetic sequence. All right, so in the last lesson, we kind of looked at arithmetic sequences in general, right? And so when it comes to arithmetic sequences, key thing here is that arithmetic, you're going to get from one term to the next, you're going to add or subtract. Right? Okay, so this formula here may look a little bit complicated. So what I'm going to do here is actually explain or show why this is the formula. All right. All right. So T1, the first term, is obviously equal to the first term. The second term, basically, I'm going to take the first term and add common difference. And then the third term, I'm going to take the second term here and add the common difference. But rather than writing that out, I'm going to write this side out here for T2. Right, so I'm going to write T1 plus D, and then I'm going to add another common difference. Right, so in other words, this is going to equal T1 plus 2D. Okay. Next up, T4 is the fourth term. Basically, I'm going to take the third term, but rather than writing T3, I'm write this one here. T1, I'm going to add plus 2D. All right, so this is T3. Then I need to add another common difference. So this is equal to T1 plus 3D. You guys see a bit of a pattern here? Hopefully you do. All right, so T5, again, rather than writing T4, I'm just going to write this one here. So T1 plus 3D. This is T4, but I need to add another common difference to get to T5 or the fifth term. This is T1 plus 4D. All right, so I don't think there's any need for me to go on. You guys can hopefully kind of see a pattern here, right? T2 is going to equal the first term plus common difference. T3, so the third term is the first term plus two common differences. The fourth term shows up. Fourth term is the first term again, this time plus three common differences. The fifth term, again, the first term plus four common differences. So key thing you want to notice here is that these numbers here, how they relate. So the third term is the first term plus two common differences. 4 is three common differences. 5, you're going to add four common differences to the first term. So notice that, yeah, to get the third term, I need to add one less common difference, right? Two common differences and so on. That's what this part means here. We're going to take the number here, but subtract 1 and multiply it with D. Okay, so that's why this is the formula for what they call the general term. All right, so the nth term. Okay, so let's apply that to an example here. All right, so in the arithmetic sequence 258 dot determine the general term. All right, so just give me one sec here. Let's write that formula again. So that way I don't have to scroll back and forth. All right, so this is the formula. You don't have to memorize this. I will give it to you on the test. All right, so Tn in this case is going to be T1. So this means first term, which is 2 in this case. Then I'm going to add. Now the n itself, it stays a variable because we just want to leave it in there. So n minus 1 times d. All right. Now d in this case, d here actually I just made a bit of a kind of jumped ahead a little bit, or not jumped ahead, but should not have written that as a d. Because in this example, we can actually figure out what the common difference is, right? So to get from one to the next, you'll notice that you're adding 3. So that means that the common difference here is positive 3. So for this d here, I'm just going to sub in 3. Okay. So, and I can kind of clean this up a bit. So what I mean by clean up is I'm going to get rid of this set of brackets. I'm going to multiply the 3n. So I get 3n minus 3. And I can also collect my like terms in this case, right? So the 2, I can combine it with the minus 3, but I also have this 3n. So we have 3n minus 1. So this is the general term of this arithmetic sequence. So if I want to find like the 5th term, I would plug in 5 for n. Now, what does this actually look like? And the reason why this is in your linear functions unit is because the general term is a linear function. All right, so in other words, remember the old slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. Well, notice here that this here is, if you were to graph this function, it would give you a line, right? It's in the slope-intercept form. All right, cool. All right, so let's say I want to find the 6th term. So in other words, I want to find T6. What I can do here, since I found the formula in part A for the general term, again, what I just need to do here is for the n, I'm just going to plug in 6. So I get 3 times 6 minus 1. So the 6th term in this case, T6, is going to be 18 minus 1, which is 17. All right. Now I can actually confirm this. What I'm going to do here, just to confirm it, I'm just going to kind of, they call it the Caveman Method, I guess. It's so kind of straightforward and simple. Basically, what I'm going to do here is I'm just going to go 2, 5, 8. I know my common difference is 3, so I add 3. That takes me to 11. Add 3 again, takes me to 14. Add 3 again, it takes me to 17. Right, and this is the 1, 2, 3, 4, 1, 2, 3, 4, 5. This is the 6th term, right? So just by adding 3 each time, I can find out that the 6th term is 17, which is what we got in the formula. All right. Now, that being said, let's say I want to find the 100th term in this sequence. It probably doesn't make any sense to write out all 100 numbers, right? So in this case, if you're asked to find the 100th term, what we need to do here is we need to actually use the formula. Right? So I'm going to find T100. What I'm going to do here is plug in 100 for n. This makes it a lot quicker. Right? So 3 times 100 is 300 minus 1. So the 100th term in this sequence is 299. I'm not going to confirm this by writing out 100 terms, all right? But it will be 299. All right, cool. All right, so let's try this next example here. We have an arithmetic sequence, or in an arithmetic sequence, the 4th term is 73, 10th term is 121. We want to write the general term of the sequence. All right, so general term of the sequence, the formula again is Tn equals T1 plus bracket n minus 1 times d. All right, so notice that to get the formula here, there's 2 things we need to find. We need to find the 1st term, and we also need to find the common difference. Okay, so this question here, it's kind of similar to one of the examples in the previous lesson. If I draw this out, I have 1, 2, 3. Now my 4th term is 73, and 5, 6, 7, 8, 9, and the 10th term is 121. All right, so this is T4, and this is T10. All right, so the equation that I can get here is to get from one point to the next. Remember, I'm adding the common difference. So here, you notice that I add the common difference 6 times, I believe. So 1, 2, 3, 4, 5, 6. Now, rather than actually having to write this out, once you do this enough time, you can see that 10 minus 4, so T10 or the 10 minus 4 is equal to 6. All right, so you can go straight to setting up the equation. 73 plus 6 common differences must equal 121. All right, so again, to get this number here, to get the number in front of the D, what we want to do here is we just subtract what I'll call the term numbers. All right, so in other words, for this example here, that would be the 10 minus the 4 equal to 6. All right, so yeah, so this equation here that we came up with, once we solve for D, then it will give us the common difference. Give me one sec here. The pen does not seem to be cooperating. Oh, no, it does. Okay, so again, I'm going to solve this equation for D, and that should give me the common difference. All right, so let me just write it up again here. So 73 plus 6D equals 121. All right, so to solve for D, let's move the 73 over to this side. So I'm going to subtract 73. So I got 6D equals 121 minus 73, which is 48. Did that in my head, and I did it correctly. All right, to solve for D, I'm going to divide both sides by 6. So the common difference in this case is equal to 48 divided by 6, which is 8. All right, so that gives us one of the numbers, the common difference. So what that means is, yeah, if I added 8 to each one of these numbers, it will get me to 121 in that position there. All right, now if I was to go in the other direction, the other thing I need to find is T1. So to go in this direction here, I'm going to subtract the common difference 3 times, right? The way that you can visually see it, or you can see that 4 minus 1 is 3. All right, so T1 is going to be 73, right, this number here, minus 3 of the common differences. So T1 equals 73 minus 3 times 8. T1 is going to equal 73 minus 24. The first term in this case turns out to being 49, I believe. Yes. All right. Cool. All right. So now I got the first term. I got the common difference. I should be able to now just plug it in and simplify it. Get the formula for the general term. All right. So Tn is equal to, so T1 in this case, the first term is 49. To that, I'm going to add bracket n minus 1 times the common difference, which was 8. All right, and just like in the previous example, what I'm going to do is expand out the brackets and kind of collect like my like terms. So Tn is equal to 49 plus 8n minus 8. Tn is going to equal, let's write the 8n first, and then 49 minus 8, which is 41. All right, so there we go. That is the general term, 8n plus 41. All right, next question or next part of this example is one of the terms, one term or one of the terms in the sequence is 209. Which term is it? All right, so in other words, it's asking you like, it's T what? All right, so it's basically asking you for the location of where 209 would sit. All right, so if I scroll it back here, you can see that this one was 121. So obviously it's going to be further down the line. All right, so your location should be greater than 10. Right? Now, the other thing here is when you're asked to find, or when it says which term is it, again, you're asked to find location. So in other words, you want to find or solve for n. Right? All right, so what I'm going to do here is I'm going to use the answer that we got in part A there. All right, so we're going to take the general term of the sequence here. Let me just get my pen to work. All right, so again, I got Tm is equal to 8n plus 41. All right, so 209 here. We don't know the location of it, but we do know that it is a term. So I'm going to call it Tn. All right, so that means in this equation on the left-hand side, I have to substitute 209. I have 8n plus 41. And now we want to solve for n, right, for this equation because we're looking for the location. All right, so to do that, I want to isolate the n. First step I'm going to do here is move the 41 over to this side. All right, so that's minus 41. So when I do that, I have 168 is equal to 8n. And then to solve for n, divide both sides by 8. We get n is equal to, that is 21. All right, so that means that, yes, 209 is the 21st term in the sequence. All right, so in other words, T21 is 209. All right, cool. How many terms in the sequence are less than 1,000? All right, so let's go back to the sequence here. So you see the 10th term is 121. This thing will increase, keep going up. Eventually it's going to hit 1,000, but we don't know how many terms is less than 1,000. All right, so this is actually similar to previous part B here, all right, where I'm going to set kind of like the limit or Tn as being 1,000. Right, and we'll see what happens here. Okay, so now to do that, I want to take my formula for the general term, which is Tn is equal to 8m plus 41. And you solve for n, all right, and use that to kind of find the location of 1,000. So again, Tn equal to 8n plus 41, right? Put it down, right? Yep. And again, similar to the previous part there, I'm gonna, for here, I'm just gonna plug in 1,000. All right, so I have 8n plus 41. All right, so to solve for n, move the 41 over to this side, so subtract 41. So that would take us to 959 equal to 8n. Divide both sides by 8. And this time we get n is equal to. Now this I can't do in my head, so I'm just going to use a here. Actually, before I do that, I just want to check, make sure I did that one right. 1,000 minus 41. Yeah, 959. All right, so in this step here, divide both sides by 8. So n is going to equal 959 divided by 8. And you see that we got a decimal. All right. So 119 point, it's at 875. Let me just confirm. All right, so that means that the 1,000 here is not actually a number in the sequence, right? But we can still answer this question. So theoretically, 1,000 would be 119.875. That would be the location. All right, so you may think that you need to round this and round it to 120, but that's actually incorrect. We don't actually, in terms of the location, we don't actually get to 120. Right, we get to 119, but we don't get to 120. So what that means here is that the number of terms that are less than 1,000 is going to be 119. All right, so when it comes to this type of question, you always round down, right? Because you're asked to find location. Okay, so So this number here, if this number is not in the sequence, but it is kind of like almost to 120, but it's not quite there. So to answer the question, how many terms are less than 1,000, we would always need to round down. So that's going to be 119 terms. All right. Cool, guys. So hopefully that made sense. And that's it. Well.